Let us prove this vector identity, that is divergence f gradient g minus divergence g gradient f, that is equal to f Laplacian g. This is your Laplacian operator, or Nabla squared g minus g Laplacian operator with operates on f. So this vector identity we can prove using the vector identity, this one what we have proved in the previous video. So watch the previous video to prove this vector identity. You have to remember the vector identities like this or this. So we know from the vector identity that divergence f gradient g, that is equal to f Laplacian g or Nabla squared g plus gradient f dot gradient g. So this vector identity you have to remember. Then similarly you can write divergence of g gradient f. If you replace f by g and g by f, then divergence of g gradient f, that will be equal to g Laplacian f plus gradient f dot gradient g. Now take the difference. If you take the difference of or subtract this from this, then divergence of f gradient g minus divergence g gradient f, that will be equal to f Laplacian g plus gradient f gradient g, this one, minus g Laplacian f minus gradient f dot gradient g, gradient f minus gradient f dot gradient g. You take the difference. If you take the difference, then this will cancel this one and this one. So in the right hand side you have f Laplacian g minus g Laplacian f. So the vector identity is proved, that is divergence f gradient g minus divergence g gradient f, that is equal to f Laplacian g minus g Laplacian f.